Yeah, guys. So let's start with this question that is given to us. So we can see here that we are given a linked list, and what we need to do, we need to delete the alternate elements that are there. Like if you try to see here that these are the elements that are there, and alternate elements need to be deleted. Let's suppose this 2 need to be deleted, 4 need to be deleted, and we can say this that this process is a little bit easy because if you try to imagine the linked list, right? Let's suppose we have this kind of a linked list that is there. Now only this thing I want to do, that I want to connect, like if this is my current node that is there, right? I want to connect, rather than currently it is connected to the next node that is 2, I want to connect it just to the next of next node. Once I do that, I'll get here 1 and 3. Now this 3, rather than connecting it to the next node that is 4, I want to connect it to the next of next, which is null in this case. So if you see here that if it is connected to null, the linked list will become empty. So this is what the question is saying, that we need to delete the alternate nodes that are there. In this case, you can see 2 and 4 will be deleted and the output will be like 1, 3, 5 will be remaining. So let's try this. Let's try this how it can be done. So let's take a big linked list. We can see this that we have 1, 2, 3. Then we have more elements which are 4, 5 and 6. Let's suppose these elements I've taken here, and let's try to just move this linked list. Yeah. Now let's suppose you are iterating in this linked list. I think you are aware of that we generally don't use head of the node to iterate. We try to take some temporary node, or we can call it as a current node as of now. So we can say this that we will call it as current node. Correct. Now what I'll try to do, I'll try to see this that I need to move forward in the linked list, and I need to change some connections as well. Like I want to connect this 1 with this 3, and I want to move directly to this 3 node. So I can find out what is the next node. So if you see, we could have written here something like this. Like if we are given a node class, we could have written node star, and we could have written node star current, or let's suppose next, it is equal to current of next. So you will see this that we will discuss it for even case as well, how the condition can be modified, but this will just help us to find out our next node. And if I write one more next, right, we can see it will give us next of next. So we will directly find 3. So what I can do is I can say current of next, and for it, in order to avoid any confusion, right, we can just write here as nxt. So if I write here as nxt, we will see that current of next, like 1 of next, it will be equal to nxt. So if I write this, what will happen? We see this connection breaks and automatically this connection is builded. Correct, that 1 is pointing out to 3 now. Now what will happen? We can see if we need to move forward, we can just write current is equal to current of next. So if you write this part, what do you think will happen? We can see direct from 1 we will move to 3, and this part only we need to do, right? If I write only these commands, it will work. Like only alternate nodes, it will get connected, and these nodes automatically they will get deleted, right? For C++ you can use a delete command. For Java, I think you are aware of that garbage collector will clean it up. So let's try. Let's discuss what will happen in case of a odd linked list. So let's take a minor example. Let's suppose that we have 3 elements in the linked list that are present. Correct. So what will happen? In this case, you will see this that you are on this particular node, which is the current node that is there. Now, if you find out the NXT node, you will be able to find out, and you know that it will be 3 because currently current of next is existing. So we can see this that this particular node already exists, and we can say it will be NXT as of now. And once you connect this, like once you connect current with NXT and you go to this NXT part, this connection will be breaking up, and we can see 1 and 3 they are connected. Next time your current will become actually this one. But in this case, can you find out the NXT node? No, right? Why? Because if you write the same part which we were writing, current of next, which will be what? It will be null. And if you try to find out next of null, then it is an error, right? It will throw a runtime error. So what we need to do, we can see as soon as we reach a last node, right? We just have to end. So at the last point, what we can say, if we are at the last node, we'll just stop the linked list, And for in this scenarios also, right, once you connect one with like 3 is connected with 5, and then you are connecting the next node as well, you will see the linked list will end. Like after 5 we will be connecting it to null in order to end the linked list. If we don't end this linked list, right, you will see this that 5 will get connected, or 5 will be connected to this 6 as well. So this is not required. We will just connect 5 with null and the linked list will be ending here. And in this case you will see as soon as we reach the last node of the linked list, we will just stop and we won't go further, right? In this case also, if we are reaching the last node of the linked list, we will just stop. In this like in even cases, you will see at the second last position only it will stop, because the next position it will automatically become null. So we will check that also. If the current node it becomes null, then we stop, or current of next it becomes null, then we stop. So if we reach the last node or the second last node, generally we will be stopping, and this way we can easily do it. So we just have to make these connections, and you need to take care about this odd and even linked list. Once you try to dry run it with more examples, right, things will be more clear, and you can take care of these cases that if there is only one element, there will be no such change in the linked list. So while discussing the code part, right, I think things will be more clear about the edge cases part. So let's move to the code part now. Yeah guys, so let's try to code this solution out. We can see this that in the approach we have already discussed that we will try to take a current pointer in order to iterate. So we can write here node star, and we can say current pointer, which will help us to iterate in the linked list. Now initially I'm pointing it to the head node. Now what we will try to do, we can see if current node it is not equal to null, and we can see one more condition that we discussed, right? For odd linked list, if you reach the last element, then also you will stop. For even case, you will see that from second last node you will be jumping where you will be jumping to a null node. So for that I have written this condition that current is not equal to null. Now we can see the next condition will be that current of next it is not equal to null. Once we see this part, right, we can see this that like the iteration condition is done. Now we just have to make some connections. So let's write node star, and we can write nxt. It will be equal to what? It will be equal to current of next of next. Now what we will do, we will try to do some connections. What connection we will do? We'll see current of next will start pointing to this nxt node, and we will try to move the value of current as well. We will say current is equal to current of next. So you will see that current it will be connected, like if we see current is 1, so this 1 will be connected to 3, and then if we move forward, right, 1 will directly go to 3, so current will be directly going to this 3 part. And this way we can do it. Once we change the linked list, you will see automatically all the alternating nodes they will be deleted, and we are just changing the linked list, right? So we are just changing the connections. So the space complexity here is big O of 1, and the time complexity is you are iterating over the linked list. So at max you are jumping on n by 2 nodes because half of them are skipped. So time complexity in this case it will be big O of n. So let's try to run this part. Yeah, we can see this is working. Let's try to submit it as well and see if test cases are passing or not. And I think this thing is clear. Just try to try run over 3-4 examples, and then you will be able to understand it better. Okay then, let's meet up in the next video.